I can answer questions later on, but in order to address this subject, you really have to go back to before the turn of the 20th century, and see what guys like Hertz and Tesla and all those and Marconi and all those kind of guys were actually experimenting with radio in general. It was really long wave radio, but it evolves later on for a lot of factors, which I'll get into what we would call high frequency radio, which I say is anything above maybe a megahertz and a half or something like that. Other people will say 3 megahertz. Army doctrine said 3 megahertz is the lower end, but it borders on that edge. But what really kicked off the U.S. Army into HF, even though we had been, there was in the office of the Chief Signal Officer, there was an R&D team component, and these guys were playing with wireless telegraphy around the same time that Marconi was, but Marconi had a lot more resources, and was building, things that he didn't even know why they were working, but he knew that eventually that if he sent out signals, he could cross the Atlantic Ocean and take it from there. He started to build a real system because he was a real great businessman. And if you wanted to use his system and his equipment, you had to pay, and you had to pay plenty. And of course, the Army didn't want to do that, so things were kind of slow in the beginning. But they started looking at things like that way back in before the turn of the century. And then along comes the Russo-Japanese War. And the Japanese also, they didn't want to pay Marconi, so they started to develop their own stuff. And the Russians at the same time were buying stuff from the Germans. Telefunken and Siemens and those guys actually existed back in those days. But when the Russo-Japanese War started, the Japanese were actually not only intercepting Russian transmissions using the German equipment, but they were DFing on the same thing. So when the big sea battle off Tsushima started, which is where the Japanese always talk about, they knew what the Russians were doing. They were doing traffic analysis, and they were also doing direction finding. And that was a big victory for them, and it kind of shook up the office of the Chief Signal Officer back in Washington, and that's what started the U.S. Army for real into radio communications, which at that time they called the wireless telegraphy. And they were doing things then that we would consider a little bit strange now. They were actually broadcasting radio signals, long-wave signals, into the ground and picking it up 5, 10, 12 miles away, and that was better than the telephone systems, because prior to that, the Signal Corps was heavy into telephones and telegraphs and signal lamps and flags and that kind of stuff. But this was the first real high technology stuff, and it was all brought on by the Russo-Japanese War, because it really shook the Chief Signal Officer up. And we didn't have Fort Monmouth yet at that time, but we had some kind of an R&D operation going in Washington, and we started looking into that. And then time goes by, and it's like pre-World War I time, and Congress starts to get involved. They are giving funds to the Army for this kind of stuff, and at the same time, the Marconi and his business associates are pretty convinced that long wave is the only thing that's going to actually bend around and get across Atlantic and that kind of stuff. And so Congress decides to give the long wave frequency assignments to Marconi and the commercial guys, and the stuff that was higher than that was worthless because it couldn't be worked with, couldn't propagate, and they didn't, whatever they thought at the time. And so they gave that part of the radio spectrum, if you could actually produce equipment that would oscillate at that frequency, to amateur radio service and to the military. Military being Army and Navy at that time. And we were pretty interested in doing something like that because there were huge numbers of ships at sea, and the Navy wanted to talk to them. And the Army, believe it or not, had more ships at sea at that time than the Navy. We had a big the Transportation Corps had a fleet of cargo ships and a fleet of passenger ships, and we were moving troops around because at that point now we had forward deployed forces in the Panama Canal Zone. We had them in Hawaii. We had them in Alaska and Guam and places like that. So the Army was also into this because we wanted to be able to command and control the ships at sea. So the Transportation Corps was funding a whole bunch of this stuff also. And then comes World War I. And radio started to really show some military potential during World War I. They had this ground wave stuff, but they also had some portable things that were like mule mounted, and they would move it around the battlefield. But it really wasn't, antenna technology wasn't there, and the sets were big, and the power levels were not high, and they had kinds of problems. But World War I started more R&D, and that ended up at Fort Monmouth because around 1917 they established the labs at Fort Monmouth, and the Signal Corps moved all of its R&D capabilities to Fort Monmouth, and things started to really take off from there. In that the understanding of what was going on with the ionosphere and that kind of stuff, and a lot of that information came from ham radio operators. Guys would be talking, on the East Coast and ground wave, and all of a sudden they're talking to some station on the West Coast, and they really didn't know why. And that started to say, well, we started to do analysis at Monmouth, and it said, well, if there was something reflecting the signals at these angles and coming down in California, then there has to be something in the ether, which they didn't even call it the ionosphere in the beginning, in the ether that is reflecting this, and we started to look for things like that. And that led to the establishment early on of two things in the Army. One at Monmouth. One was the U.S. Army Radio Propagation Agency, or its predecessors, and the Institute for Exploratory Research. And we had all these I wouldn't call them engineers. They were more like theoretical physicists and mathematicians and those kind of guys on the payroll at Monmouth, trying to figure out what was going on with these signals, that we were able to go these tremendous distances. Marconi knew all about this. He was making a fortune. Almost every ship at sea had a Radio Shack. If you remember the corporation called Radio Shack, they had a Radio Shack on the deck with a dipole antenna or an inverted V, and they were talking ship to shore and ship to ship. And when the Titanic, which was like 1912, went down, that's where things really started to take notice, because the shore stations of the Marconi Company, particularly one guy named David Sarnoff, and I'll know more about him in a second, were able to vector the rescue ships eventually, and the big problem there was the radio operators didn't do 24/7, so a lot of them didn't get the word until like the next morning, but they were able to vector the rescue ships using Morse code and Marconi's shore stations. And Sarnoff became very famous, and that's important. I'll tell you why. Because Congress gets back in the act and says, this stuff is kind of more important for national defense, and we're depending on Marconi, who was a foreigner, who later was a supporter of Mussolini and was quite a fascist, by the way, and we don't want that. So what we have to do is we have to get one of our own private company going that can look into all this radio stuff. And who are we going to get to head it? Well, the only famous radio operator in America was Sarnoff, because he stayed at the key for about 48 straight hours vectoring all these rescue ships to the Titanic, and his name was well known in the newspapers and everything. So ipso facto, and here we go, and Congress pushes, and we get the Radio Corporation of America, RCA. and Sarnoff is the head. And later on in the Second World War, he gets sucked into the Signal Corps and ends up as a general. But the real thing there was Congress decided that we have to get into the radio business somewhere for national defense reasons. And so that's where RCA came from. And now the Army gets a little bigger in the 20s because we're now starting to become a world power. So we have a little problem here. One is we've got post camps and stations everywhere. And how are we going to tie these guys together and depend on telephone service from the Bell system, or we need some kind of a backup? And that's when we started to build the CONUS-wide HF net. And it went across the Pacific because we had Army bases in Hawaii, and we had some in the Philippines, and we had a big effort going in Alaska. And so then that begot the Alaska Communication System, which guys, because there was no phone wires and there wasn't any possibility, they weren't running phone poles all the way out to Fort Wainwright and places where they were. So we start building these big 10 kilowatt and 50 kilowatt radio stations to tie all the Army post camps and stations together. They are appreciated because the guys at Monmouth are now designing things like rhombic antennas, and they're up on 90-foot telephone poles, and they take 10 kilowatts of power or 50 kilowatts of power, but they exist. And so in the 20s, we're starting to build these post-camp and station arrays. And if you take a place like Monmouth, which was basically the net control for all of this, Washington being the second place, they discovered things like receiver dual diversity, which means if you put up two antennas and you separate them by X number of wavelengths, when one starts to get an atmospheric fade, the other one probably won't, and you can combine the systems at the receive site, and things improve. So if you looked at Fort Monmouth, about 15 miles north was Camp Coles, and 15 miles south was Camp Evans, and both of those places had rhombic antennas in the network pointed to different places, and depending on what they were interested in, up on 90-foot telephone poles, and they used that dual diversity, and that made the system even more reliable. So now we end up at in the 20s with these big facilities and a military communication system that relied on HF radio because there was no satellites or anything. So that's what they had to use to get places where telephones just weren't there. And that's how we went through the 20s and into the 30s. The HF systems then got tied to what we call the comm center. And what you had in there was teletypes, the old Kleinschmidt teletypes, which stayed in the Army for probably 50 years, and a thing called a torn tape relay. And the HF systems would punch out, had a modem, and it would punch into the long paper tapes. And if you had communications between Station A and Station B, and you wanted to go to Station C, but you couldn't get directly, you stuck it into another machine, and it relayed. And that was basically, we went through the 30s and even through World War II with these torn tape comm centers sending teletype over HF. And that was quite an extensive system, and every post camp and station had some kind of entry into it. And we learned a lot about HF, but that was what you would call strategic HF. The tactical HF came a little later, maybe in the mid-30s, and they actually had a mule stable at Fort Monmouth, and these mules were equipped with those side saddles, and HF radios were on there. There was an antenna set up with each of them, and all the echelons below post camps and stations, the tactical units, got a signal organization beginning usually a company size, but grew later on to World War II into a battalion size signal operation, and they were using HF radio to back up telephones, which were basically the major use. What we wanted to do was telephones, but you couldn't do it, so we went to wireless HF radios. And then along comes a guy named Heinz Guderian, who was a German general, who some of you guys may recognize the name. And he says the next war, what I'm going to do is, instead of controlling all my tactical units from the rear with a telephone, I'm going to control them from the front with a radio. And when he said radio, he meant either Siemens or Telefunken or one of those guys' HF radios, because the technology had gotten to the point where they could do that. And so that was the birthplace of tactical HF, because DA again, or at that time it was still the War Department, panicked again. The chief signal officer said, "We read Guderian's book, and if he can do this, we better be able to do it too." And so that was interesting, because Guderian was the father of the Blitzkrieg, and he started life in the German army as a signal officer. And I don't know if anybody else, maybe the Canadians did once, take a signal officer and put him in a high tactical position, but the Germans sure did. And the boys at Monmouth read his book and went into a panic, and then we started a big tactical HF effort. And how did we do that? They established two things. One was the Institute for Advanced Research, which was a bunch of theoretical and practical physicists trying to figure out how to make oscillators and what kind of antennas you would need, and did a big thing on antennas, because everything depended on antenna and frequency. And the other thing they produced was the U.S. Army, what they call it, Radio Propagation Agency. And these guys, into the 60s even, maybe even into the early 70s, would publish a telephone book size, the thickness, of a telephone book, of antenna predictions. They had some kind of, later was automated, but they had some kind of a calculation. They could measure the height of the ionosphere, and there was a guy at Fort Monmouth, even into the 70s, who was out in one of the remote areas near the fort, and what he was doing was measuring the height of the ionosphere for their calculations. And they would give you like a matrix, and it would say, this antenna, you want to go from this point here to this point there, you need this antenna, you need this power level, and then they would calculate the maximum usable frequency and the lowest usable frequency, and they'd knock some, like 80% off of that, 10% off the bottom and the top, and say, these are the frequencies you need, this is the antenna you need. And every time the sunspot cycle changed, or the unit moved or something like that, you'd get a new prediction. And these things were, when I say big, they were thick as the Manhattan phone book. And if you knew how to use it, you could figure out which antenna and which frequency, and that was the key to that. And they were in existence probably, I got to Monmouth in 1960, well, I came back from Vietnam in 1970, and they had just abolished them. They took all the frequency engineers and all of those guys, and they put them in the ComADP lab, but the two agencies were both abolished in the early 70s, and that was probably a mistake, but people were starting to look at satellites, and they didn't need them, and there was budget problems, and that gets us into a real fight in the Army over money, and not so much over technology. It was basically over money. We had the UHF SATCOM, and everybody said HF is out. We can get more messages through. We don't have to deal with antennas other than pointed at the satellite. We don't have to deal with the things that happen in propagation, sunspot numbers, all of that kind of stuff. We don't need it. We'll go to satellites. And pretty much people, we had at that point in the signal battalions, we had HF radio teletype, which was very handy. But that was the GRC 106 series of radios, and it just had a simple modem. It was basically a tone pack. And They worked. Prior to that, we had the Angry 26D, and it also worked, and it was tied to a mechanical teletype that Kleinschmidt made, and it probably was out in the Army probably for 50 years. And that was where the Signal Corps started to say, you know what, we don't want to do this HF stuff anymore. It's too hard. The guys down at that time, Monmouth had moved most of the signal school to Gordon. They really don't have a handle on this, and we're all going to satellites. And at that point, things started to get political, and I was involved because I was assigned at that point to the PM SINGARS. And SINGARS, everybody thinks of as the SINGARS, the tactical radio, VHF radio. But the office was actually SINGARS across the band, and anything that was single-channel tactical radio. The SINGARS V, if you looked at the original documents, it said SINGARS V. That meant VHF. There was also a SINGARS H, which never really got off the ground. And there was a SINGARS U, which was supposed to be used for ground-to-air, and everybody kind of looked at that as the peripheral, and SINGARS V became the big effort. But one day the colonel calls me in, Colonel Wyatt, and he says, we got a little problem. I understand you know a little bit about HF radio. I said, well, when I was in Vietnam, I ran the Mars stuff because we had done away with HF basically in Vietnam. At the strategic level, we had what was called the IWCS, and that was base camp to base camp with 120-foot billboards, and it was troposcatter, and there was no HF there, but tactically down in the units, there was a whole bunch of HF, and we contracted with SRI, Stanford Research Institute, and they went out into the jungle with PRC-74s, man-pack 20-watt radios, and did a big study about how to tie together the special operations guys and other people that were out in the boondocks with HF radio because the VHF ground wave would just run out. And they did a nice study, and the conclusion was that HF would work in the jungle and in the other parts of Vietnam on the tactical level. And so people kept supporting that, and we got PRC-74s. And when Wyatt called me in there, he said, we got a thing for special operations called PRC-70, and that's going to be HF and VHF because the A-teams didn't want to carry two radios. And there's a whole story. I can give you a story behind all of this stuff individually, but I don't have enough time. So that kept HF alive for a while, and then there were other people in the Army who said, you know, this satellite stuff, maybe yes, maybe no, but for things like motorized reconnaissance and cavalry units and people like that, we still need some tactical HF voice radios. And so the GRC-106 was the radio that was in the radio teletype set. It's also a voice radio. So we were building those, but that was still a lot of old technology. And so they said, well, we need another piece of equipment called the IHFR, the interim high-frequency radio. And that became another thing that was actually funded. And the result of that was the PRC-104 family of HF radios. And every once in a while, you know, it was almost dead, but something would come up and it would save it. And the next thing that saved it was a thing called strategic arms. If you went to Germany, we were deploying the 56th Field Artillery Brigade, which was a Pershing missile, and also the 59th Ordnance Brigade, and their job was to give nuclear weapons to our allies, mostly 155 artillery rounds, and we had to command and control that because those were nuclear weapons. Congress jumps back in the picture again and says, how are we going to command and control these guys? And the answer was, we're going to use UHF SATCOM. And they said, not good enough, Army. We need a second way to get to these guys because maybe the satellite will disappear or maybe it'll get jammed or whatever. And these were congressional staffers who were doing this. And they said, we need a second way to go, and the only other way to go was HF. So a thing called regencynet became a project. And there was already, by the way, an HF net out there using mostly Collins KWM-2As, which the Army called FRAC 93s. probably the highest limit of tube technology before we went solid state, and those radios were great. But again, they were fixed station. They put out a kilowatt. And once the guys moved out of the cantonment area, what are you going to do? So we had to have the interim HF radio, and they funded that for the tactile units, and they funded the regencynet for the higher echelons. And that contract was executed. They were starting to get the stuff into Tobyhanna Army Depot, and President Reagan signs the Strategic Arms Limitation Treaty, and the Pershing Brigade disappears. And so does the 59th Ordnance Brigade, and all those nuclear weapons go into the scrap heap, and we have a yard full of truck-mounted HF radios sitting at Tobyhanna, and the contract was for the radios was actually an Italian company. There's a whole story behind that, too. And so regencynet stuff, except for the trucks and the generators, got scrapped. And I would have loved to have taken that and given it to Mars or given it to whoever, but we weren't allowed to do that, and that stuff all got scrapped. But the money that came in from that also funded a whole bunch of R&D, and from that we got improved modems and improved antenna stuff. And so regencynet did something for the Signal Corps, but it wasn't what it was intended to be. And that brought us through, through the 70s. And again, the Army politics were out to kill in the signal battalions anything with HF. And so along comes a guy named Al Gray, who was, at Gordon. And he says, you know what? Maybe there is some use for some of this HF stuff, but not in the signal battalions. It'll all become user-owned and operated. And that was a real disaster because the Signal Corps wanted to wash their hands of all this stuff and say, user-owned and operated, infantry, if you need it, you take care of it at the infantry school. We're not in that business anymore. And that kind of stuck a little bit, except guys like SOF and mostly SOF, decided that they still needed HF radios, and they got some funding because SOF was the apple of everybody's eye in those days, and they got some funding, and we started to develop things like the PRC-70, which was the first really fully solid-state man-pack HF radio. It also was VHF. And that kind of killed everything but SOF and Lursu and guys like that, and special mission stuff. And the Signal Corps said, "We're done. No more regencynet. No more radio teletypes in the signal battalions, and we're all going to satellites." And that kind of stuck that way for a while, but along comes Congress again. This time it was the Senate, and a guy named Barry Goldwater and his congressional counterpart, which is a guy named Nichols, come up with a thing called the Goldwater Nichols Act, because there were some lessons learned in Vietnam that commanders wanted stuff and couldn't get it. And the reason they couldn't get it was because the Army system wouldn't allow them to get it. We had programs, the programs produced hardware and training and maintenance and that kind of stuff, and that's what you got. So if you were a program of record, and that's what they called it, program of record, you got what the program gave you and nothing else. And Goldwater was talking to corps commanders and division commanders, and they say, we need stuff like HF radios and sniper rifles and the whole long list of stuff, and we can't get it. And so the Goldwater Nichols Act said, well, if you need something and you present the Army staff with a thing called an ONS, Operational Needs Statement, then G8 has to fund it and you're going to get it. And they made that stick because Goldwater was a big-time politician. And that saved a lot of things because along comes SOF and they say, we need HF radios. And what kind of radios do you need? We need the Harris 138s. They'll do our mission. We can send A teams out, and they can talk to the base camp and all that kind of stuff. And here's an ONS G8. You got to fund it. And that by that time, I was working for PM Tracks, Tactical Radio Systems. And again, the colonel says, "You know something about HF radio? Nobody else does. You're in charge." And so I said, "Well, okay, what are my resources?" And they said, "You got a pile of money here from G8 and a operational needs statement and a and the go ahead and be in charge. Anyone you pick, you're in charge." And I thought that was great for me. They gave me all the resources, and we ended up with the Harris 138, which SOF already said that's what we want, and they could do that, but we had to go and do a little field test to prove that it worked and that kind of stuff. But basically, that's where SOF started doing with the 138s, and along comes Desert Storm and Desert Shield, and there was another system out there that I really had very little to do with. It was called Goldwing, because the guy who dreamed it up was a guy in TRADOC named Chuck France. And why did he need it? Air weather. The Army was supposed to provide the hardware for the Air Force Weather Service guys who are located down to brigade level so they can intercept the Air Force, because the Air Force never gave up HF, the Air Force regional broadcast of the weather. And that became an MI mission, and we got to come up with something, and we have no program or anything. So France comes up with this cheapy Transworld radio, if anybody ever saw one of those. And they came in a suitcase, and a grid compass, if that name rings a bell, laptop computer, and a modem, and he's going to intercept the air weather stuff. And they went to Desert Storm with that. And what happened in Desert Storm was everybody was moving so fast, they outran MSE, which I worked on also, and nobody could talk from the area commander, Schwarzkopf, down through the corps, down to the division, and even below. And so they're up at headquarters here, and the air weather guy is sitting in the corner intercepting the weather, and somebody says, "Where's the 7th Corps, or the 5th Corps, I guess 5th Corps, where's 5th Corps?" And nobody's got an answer. And the weather kid says, "Wait a minute, I just talked to him with my Goldwing. I could ask him where he is." And they said, "Well, do that." And he got an answer. And then all of a sudden he got answers from all the other divisions and brigades. And even the coalition guys were in on the weather thing. And the signal officer says, "This stuff is too important for weather. We're going to use it for command and control because we don't have MSE working. They're moving too fast." And so all of a sudden, whoa, HF could be doing that kind of stuff. And that's what they did as they moved into Iraq. So now people start to take HF a little more seriously. And along comes the Harris Corporation. And these guys were another bunch. Every time there was an ONS, the Harris guys either instigated it or knew about it, and the answer was HF radio. They first had the 138 that they were selling to SOF, and then they had the 150, which they were improved version. And the Harris guys saved HF for the Army, again, on the tactical level, because they had all that stuff off the shelf ready to go, and the ONSs kept flying into my office, and we kept calling up Harris and sending them money and hiring their training teams and all of that stuff. And we got that whole thing out to the Army towards the end of Desert Storm and then beyond that. And other people were now looking in there, and more ONS were coming in. And by the time I left in how long have I been retired? 2005, we had spent on Harris radios between that and their 117s, maybe $4 or $5 billion with a B, a good chunk of which was 150 HF sets. And the guy who took over from me told me we spent a couple billion more than that. So I think they're over the $6 billion mark in Harris, basically commercial radios, not commercial, but built to mil spec. including a big number of HF sets. And let's see, they're still out there. All those mine-resistant vehicles have got HF antennas on them. We did a lot of HF work, and along comes the guy who was the project leader for JTRS, or at least the Army portion of JTRS. And they had lots of money and no hardware because the only thing they were able to produce was a library of software waveforms that would go into a JTRS if we had a JTRS. And the Harris guys come out of the woodwork again, and they saved the day by taking that library and programming it into either the 117 or the 150 HF, and it worked. We could have quick to the Air Force. We could all kinds of waveforms that nobody ever used except for special operations guys and clandestine operators. Everything got programmed in there, and it all worked. And it all was done on JTRS money. And then they said, you know what? The Harris stuff does everything that JTRS does, or 99% of it, and we don't have to go out and spend all this R&D money. Let's just buy them. And so that's how we ended up with the 117s and the 150s. And HF was a big part of that. And the Signal Corps still washes its hands of all that and says it's all user-owned and operated. And I think that's pretty much where we stand today. In a nutshell, every one of those things that I said has got a story behind it that I could spend days probably talking about, IHFRs and all that kind of stuff. But Harris, the SOF guys, the air weather guys, and the regencynet, 59th Ordnance Brigade, and the Pershing Brigade saved HF for the Army, and right now it's still there. They did a big study with when they started talking about coalition warfare and civil-military interface. They contracted with, I think it was Stanford Research or one of them, or MITRE. And they came around and they tried to decide what organizations have radios in common that we could use for that kind of situation where you had to do civil-military and coalition and all that stuff. And they came to me when I was still in the New Jersey National Guard, and I said, the answer is everybody's got single-channel HF non-encrypted. And they did a year and a half study, and they came back and said, everybody's got single-channel non-encrypted HF. So there was a big use there, the old Civil Defense Organization and all that stuff. And on the side, then we have the Mars operations. Mars was very big into HF. Every Mars station and every post-camping station, including in Vietnam, had a FRAC 93, which was a Collins KWM-2A, and Collins also saved HF because that thing worked so well. And I don't know what happened to all that stuff. I guess it's now been replaced, but the stories behind all of this stuff, but that's HF in the Army in a nutshell. The Signal Corps really wants to wash their hands of it, but every time the commander turns around and something's not working, they blame the Signal Corps, so they have to do a little bit of HF. I don't think Gordon is doing much at all with it. The frequency management guys are doing something, but somehow the users, mostly through Harris training teams, keep this stuff going, and it's accomplishing all kinds of missions.